Two of the most interesting exoplanets found so far, 55 Cancri F, a gas giant planet in the habitable zone of its star, and TrES-4b, a ridiculously large world that's perimeter can almost occult its entire star. It's time to look at these worlds in a bit more detail. Hi everyone, Vega here, and in today's video we return to our exoplanet series to study and consider these two incredible potential worlds. So let's get to it. Starting with 55 Cancri F, this gas giant exoplanet completes its orbit around its parent star, 55 Cancri A, at a distance of about 0.77 astronomical units. 55 Cancri is actually a binary system of a K-class orange dwarf and a smaller, much cooler M-type red dwarf. The planet is in orbit around the orange dwarf, and given the star itself is less powerful than our Sun, its habitable zone would look something like this. Despite considerations of size and composition and proximity to its parent star, 55 Cancri F does not qualify as an Earth-like planet. It probably lacks a solid surface and resembles a gas giant akin to Jupiter in our solar system. As yet in our observations, and notably, 55 Cancri F has no known moons, but the search for potentially habitable moons continues. I'm willing to stick my neck out here, making an assumption that the wonderful world probably has many moons indeed, much like all the gas and ice giant planets of our own solar system. Any one or indeed many of these moons quite easily be habitable, and even resemble the worlds of Ganymede, Titan or Kiilstofte, but with warm Earth-like temperatures. Strangely enough, 55 Cancri F is another exoplanet that to some extent has a given name. Many affectionately know the world as Harriot, in honour of Thomas Harriot, the English astronomer from the 16th and 17th centuries. That said, the official designation of this exoplanet does remain at 55 Cancri F, following conventional astronomical naming practices. Of course, there are problems associated with moons in orbit around large gas giants, and 50 Cancri F is no exception. Any moon is likely to experience tidal locking, similar to many moons that orbit gas giants in our own solar system. Tidal locking entails the moon's rotation period matches its orbital period, resulting in one side of the moon constantly facing the planet, the near side, while the other side always remains turned away. This has benefits for moons closer into the planet, which means a shorter day-night cycle. But on the other hand, those very same moons may also be plagued with high radiation levels emitted from the host world, much like Io and Europa in the Jovian system. Io, for example, has a day of around 42.5 hours, but receives about 3,600 rem of ionizing radiation per day. At doses between 300 and 400 rem, without medical treatment, there's a 50% chance that a person will die within 60 days. Kiilstofte, on the other hand, also tidally locked to Jupiter, has a rotation period of about 16.7 Earth days, which would make a very, very long day, but radiation levels of just 0.01 rem per day. Of course, Jupiter also has 79 confirmed moons, so if 55 Cancri F is anything like it, then we should expect to find many worlds indeed, and perhaps worlds that have a happy medium resting between the two. The truth is, though, that also sometimes moons can exist many millions of kilometers away from their host world. Indeed, the moon NASA, which orbits Neptune from a distance of a whopping 0.33 astronomical units, or 49.5 million kilometers, completes an orbit in an astonishing 26.5 years. At present, there is no definite information whether NASA is tidally locked to Neptune, but the likelihood is the further away, the more likely it is of having a stable day-night cycle, irrespective of its host planet. So perhaps a moon that would be a bit like NASA around 55 Cancri F could enjoy the best of both worlds, so to speak. Likewise, Saturn also has 83 moons, Uranus 27 and Neptune 14. So again, it's likely 55 Cancri F has many moons. In this graphic, we imagine the bright view from one of the moons of 55 Cancri F, the star shining brightly at -26.83, which strangely enough is almost an exact replica of the Sun in our skies. In the distance, we see many moons circling the huge swirling world. When talking about exoplanet TrES-4b, we first have to make clear that it's not and probably never will be a habitable place, no matter how many moons it has. TrES-4b is classified as a hot Jupiter, and its orbital distance is exceptionally close with a semi-major axis of just 0.049 astronomical units. As a result, it has an extremely short orbital period and completes one orbit at around 3.55 Earth days. Not only that, it's in orbit around a hot F-class star, which is a bit like Procyon, so it's not the usual red dwarf either. No, the interest in TrES-4b is that it's known for being one of the largest exoplanets discovered in terms of physical size. a radius approximately 1.7 times that of Jupiter. It is the largest known exoplanet, and indeed is so large that it can eclipse its host star when viewed from Earth. The weird paradox, though, about this world is despite it being so much larger than Jupiter, it remains significantly less massive, and consequently is also the least dense known exoplanet. Like Jupiter, it's likely that TrES-4b primarily consists of hydrogen and helium, but the extreme proximity to its parent star and an estimated temperature of 1782 Kelvin means intense heating could lead to a unique atmospheric properties. These properties, again, are caused by proximity to the parent star that's over 4 times more luminous than the Sun. In our graphic, we imagine a ginormous yellow-white F-class star in the sky, and we view TrES-4b from the vantage point of perhaps an exploring spacecraft, as it's unlikely this world has stable moons. Procyon-like star shines at a dazzling -35 apparent magnitude, making viewing extremely difficult. 55 Cancri F, a Jupiter-like world in the habitable zone, and TrES-4b, a gigantic yet lighter than balloon-type world in an orbit around a hot subgiant star, make up 2 of the most interesting exoplanets in our vicinity. Worlds such as these sometimes could have habitable moons, but that depends a lot on the distance and orbit around their host stars. As telescopes improve, we hope to learn more about these strange worlds, along with many other worlds that we may find in our searches. We wait patiently, considering and anticipating the fascinating results. Thanks for watching, and consider subscribing if you haven't already. If you would like to support this channel further, you could consider buying me a coffee, and I'll link this in the description. Thanks to those of you who have already done so. If you have any videos or subjects you'd like to see brought to life, don't forget to let me know in the comments below, and it could just be your idea next week that shows up. Take really good care of yourselves, look after your friends and family well, and I'll see you on the next one.